In today's tutorial I will solve a problem on design of compound reverted gear train. We will have to design this gear train. We are given that the power that will be transmitted through this gear train is equal to 25 horsepower and the input speed or the speed of gear 1 is 2500 rpm. The desirable speed that we want to obtain at the gear 4 should be between 280 and 300 rpm. Here the spur gear pressure angle is 20 degree. We will have to find out the number of teeth on each gear, and we are required to try to minimize the gearbox as much as possible, and we will have to avoid the interference phenomena as well. And in the part B we are required to find out the number of teeth, or we are required to design a gearbox based on helical gear. And the pressure angle over there is 20 degree and helix angle is 30 degree. So let's move towards the first part. So first of all, as we want to reduce the speed from 2500 to 280 rpm, so n1 divided by n4 will be equal to 2500 divided by 280 or 2500 divided by 300. So this is the speed ratio that we are required to have after designing the gearbox. As gear 2 and gear 3 are on the same shaft, so if we multiply n3 by n2 over here, it will cause no harm because they can be cancelled out with each other, and we can rearrange it like n1 divided by n2 multiplied by n3 divided by n4 as v1 is equal to v2 because both are meshed with each other, and if there is no slip then velocity of gear 1 will be equal to velocity of gear 2 and v1 will be equal to r1 omega 1, or instead of omega we can put n1 because it is the revolution of the gear 1. Similarly v2 will be equal to r2 n2. Now if we multiply 2 on both sides, so 2r1 will give us d1 and 2r2 will give us d2. Now rearrange this equation. So n1 divided by n2 will be equal to d2 by d1, and as we know that module m is equal to d divided by number of teeth, we represent teeth by t over here. D will be equal to mt, so d1 will be equal to mt1 and d2 will be equal to mt2. So this m and m can be cancelled out with each other. We will get n1 divided by n2 is equal to t2 by t1. So you can see that instead of n1 divided by n2, t2 divided by t1 over here. Similarly, if this is n3 and this is n4, so this will be t4, this will be t3. You can see that we have put t4 by t3 over here instead of that. We have further simplified the equation by calculating this and this, and to avoid the interference, the number of teeth on the pinion can be calculated from this formula. Here this k will be equal to 1 for full depth, and this m is mg, not the module, and mg is the ratio of their speed n1 divided by n2. Here we can reduce the speed in 2 steps. We want to reduce that speed by half amount over here and half amount over here. The speed ratio, that is n1 divided by n2, will be equal to n3 divided by n4. So if we put n1 divided by n2 instead of n3 divided by n4, we will get this. So we can square it. This will be crossed. So n1 divided by n2 whole square will be equal to 8.92 or 8.33. Similarly, if we put n3 divided by n4 instead of n1 divided by n2, so we will get n3 divided by n4 whole square is equal to 8.92 or 8.33. And to find out the value of n1 divided by n2 or n3 divided by n4, we will have to take square root on both sides. So we will get n1 divided by n2 equals to n3 divided by n4, that will be equal to under root 8.93 or under root 8.33, which will give us 2.89 or 2.99. So this is the ratio mg. As I told you, this mg over here in this formula is represented by m, so put m to be equal to 2.89 over here and k to be equal to 1. Similarly, this pressure angle is 20, so when you put these values you will get this one, and after the calculation you will get 14.91 teeth on the pinion. If you see over here, the gear 1 for you is pinion because it is smaller gear, so t1 will be equal to 15 because we cannot get half teeth. So T1 is equal to 15. Now as you see, N1 divided by N2 is equal to 2.89, and as I told you earlier in the calculation that N1 divided by N2 is equal to T2 divided by T1. So multiply this T1 over here, and instead of this T1 we have put 15 teeth over here. So on the gear 2 you will get 44 teeth. And similarly, if you see over here, N3 by N4 is also equal to this 2.89, which is represented by mg, and put this mg over here. This is 2.89, and for the full depth k is equal to 1, and the angle for gear 3 is also 20. So putting these values, it will also give you 14.91 teeth on the pinion, and the pinion here is 3 because it will be smaller than N4 to reduce the speed of the gear. So T3 is equal to 15, and T4 divided by T3 is equal to N3 divided by N4. So T4 by T3 is equal to 2.89. So multiplying T3 on both sides, it will give you T4 is equal to 2.89 into T3. Instead of T3 you will have to put 15. So 15 multiplied by 2.89, it will give you 44 teeth. So this is the design of compound reverted gear train based on the spur gear. Now in the second part, as we are required to have the design for the helical gear, for which the pressure angle is 20 and the helix angle is 30. These are all the previous calculations that will be needed over here as well. And to avoid the interference, the number of teeth on the pinion gear can be calculated based on this formula as given in the problem, that this is 30, and this can be calculated from this formula. This one is the pressure angle 20, and this one is, I told you, equal to 30. So putting these values, that will give you 22.796. So put this one equals to 30 and this one equals to 22.796, and this m, as we previously calculated, to be equal to 2.89. So put all these values, it will give you 10.12. So this is the number of teeth on the pinion. As I told you, gear 1 is the pinion gear, so T1 will be equal to 10.12, and as we cannot take half teeth, so it will be equal to 11, or you can take it to be equal to 10 as well. When you take it to be equal to 11, and taking this N1 divided by N2 is equal to T2 by T1, multiply this T1 over here, which is 11. So when you multiply 11 with 2.89, it will give you 32. And similarly, you will have to calculate the number of teeth for the gear 3 and 4 as well. Gear 3 is pinion, so T3 is equal to TP, and TP have this formula. This pressure angle is the same, and this angle is the same, and this angle is the same, so you will get the same angle this as well, which is equal to 22.796, and M is also the same, so you will get T3 equals to 11, so T4 will be equal to 32. So this is the design of compound reverted gear train based on the helical gear. Here I want to mention one thing. In both the cases, if you use this 2.99 instead of this M, then the teeth on gear 1 and gear 3 will be the same like the design that we have done, but T2 and T4 will be different, and the T2 and T4 that we have designed will be less than the one that you will calculate based on this 2.99, as in the problem we are given that we have to reduce the size as much as possible. So that is why we have designed based on this value, not on this value.